Right guys, so actually I have uploaded a video in the morning, but I think I have given many wrong answers in that, so I had deleted that video and now I'll try to give uh, the confirmed right ones. Okay, in the morning I gave some hit and trial answers, but yeah, they were wrong, I agree. Like later I have checked the references where I have found it to be the wrong one. Like it's my problem, I don't observe the question properly and then feel that what I have thought is the right one. Okay, I apologize for that. I'll try to give few right answers to the few other questions other than what I've told in the morning. Maybe the morning ones I'll just in the end of the video I'll just give a brief thing, but few others I'll try to make a video over here. Okay, so this particular question, that is for the catalytic activity of copper and zinc containing enzyme superoxide dismutase, which is or the correct statements. Okay, so which of the following is a correct statement is that the SOD structure is this particular thing. All the histidines will be present and one is the bridging histidine. And in this particular superoxide dismutase, what happens is that superoxides are being generated in our body. Okay, so to inhibit them, we have to intake this SOD in some form, in some mineral form. Okay, so what is the most important, the anti in an anti-way acting towards a superoxide is copper. Okay, the copper is the main mineral. Zinc is like an additional thing present in a bridging with copper. Like I'll not say that zinc is not required, but apart from zinc any other metal can be present here which can enhance the activity of copper. It need not be zinc. Okay, so copper, yes, copper is the main element, and I think zinc is just, it can be replaced by any other metal if I am not wrong. So the correct option should be B and D, that is only copper is essential. Zinc may be replaced by any other divalent metal ion. Okay, so this particular question, and then the degeneracy of the cobalt in the ground state. Right, this particular question, the total degeneracy. So how do you solve this particular question? First you have to find out the ground state, because he has asked for the ground state. Now how do you calculate the ground state? The ground state, you will calculate from this particular d orbital configuration, d7 cobalt 2, right? Now calculate the L value and S value from this. What is the L value? 2 into 2 plus 1 into 2, 0 into 1 minus 1 into 1 minus 2 into 1. So that will give you the L value to be 3. Okay, the capital L comes out to be 3. And then 2s plus 1. To calculate the spin value, what is the formula? 2s plus 1. So 2 into spin is, this is 0. Half plus half plus half. 3 by 2 plus 1. So 4. Right? So 2s plus 1 is 4. Now how do you write your term symbol, or the ground state term symbol? A general thing is this character, spin and J value, right? So this term symbol, not character, term symbol is F. Now why is it F? Because L value is 3. Like L is, the sketch is not writing. Okay, 0, 1, 2, 3, S, P, D, F. Okay, so it is F. 2s plus 1 value is 4. And what is J? When it is more than half filled, it is L plus S. Had it been less than half filled, it would be L minus S. So 3 plus 3 by 2. So 3 to the 6 plus 3, 9 by 2. Okay, so this is your ground state term symbol. Now once you have found out your ground state term symbol, from this you have to calculate the degeneracy, or in the other words, the number of microstates. So what is the formula? 2s plus 1 into 2l plus 1. So 2 into 3 by 2 plus 1, 2 into 3 plus 1, that is 4 into 7, 28. So I think the answer should be 28. Don't rely on any of my answers. This is just my opinion about the answers. Okay. You are welcome to comment down if I go wrong anywhere. Not a problem. I learn from you. But do not rely on the answers that these are the exact ones. Okay. And among the elements, the one with the lowest first ionization energy, of course it is gallium, because if you write the electronic configurations, in the outermost shell for the gallium will be having 2, 1 configuration. So if you remove one electron, it will attain the stable configuration. So removal of that one electron is very easy, as it wants to attain the stable configuration. So gallium is the right choice. Okay. And then this I actually, went wrong in the exam thinking that he has asked the metal carbon bond, but it was actually CO bond. So if I go on that basis, I think option 2 should be the right one. Like, I want to explain, but I'm scared that if it will be right or not. Okay. Anyways, I'll give my explanation. Let me know if it is right or not. So CO bond length. Okay. So vanadium, if it is having a negative charge on it, it means vanadium is having excess electrons in it. So once vanadium has excess electrons, it will give away its electrons to the anti-bonding orbital of the carbonyl. Okay. So once it's give its electron to the anti-bonding orbital of the carbonyl, the stretching frequency of CO decreases and the bond length also decreases. Okay. As the stretching frequency of CO decreases, the bond length decreases. So according to that, I thought the option should be this A option, right? But some of my friends told that B is right one. Again, I'm getting doubt that mine is the right one. See, just think about it and let me know. This is the explanation. As the electron enters into the antibonding orbital from a filled metal orbital to a vacant pi star orbital, what happens as the electron is entering into the antibonding orbital, the stretching frequency decreases. Now, as stretching frequency decreases, bond length also decreases. Okay, decreases. Yeah. So as this decreases, this should be the least value. Right, this should be the least value. Then A should be the right option. Think about this question and let me know what is the right one. Okay. And then what else can I tell you? I think these are okay. Like this question, I think it is wrong because how much ever you try, you will not get 2.9 and 4.1 for one particular metal. Okay. So don't know. Try out that, and this is easy. The transition LMCT, and what else is there? Yeah, this thing, inorganic. Organic, yeah, one question, maybe I knew it. Trans-tecylene and cis-tecylene. Trans is more stable than cis, if I am not wrong, right? So A is more stable than B. And here this is aromatic because delocalization is involved here and 6 electrons are present. Here this lone pair is also involved. 8 electrons totally are involved. 4n plus 2 is not satisfied, so I guess A is aromatic and B is anti-aromatic, right? And then this is wrong. Correct option is proportional to A and B. Okay. Like I'll solve it separately, maybe afterwards, in a paper. Okay, now I'll just tell in brief. The term symbol for the ground state of boron B2 molecule. Like you'll be having 3 term symbols for the boron. You'll be having this, you'll be having even this, and a delta one also. Okay, you'll be getting 3 term symbols. Like it's a big derivation. Okay, I'll do it some other time. Just look for the answers. So among all those 3, this is the most preferred one. Triplet sigma G minus. Now this is according to the Hund's rule. From the Hund's rule, we say that for among singlet and triplet, triplet is preferred. Actually, the triplet is not preferred. If you go with the general, the general concept, but from the Hund's rules, you come to know that triplet sigma G minus is the right one. Okay, and this particular Gaussian distribution, I have found it like 2 by square root of 2a square pi e power minus x minus mu whole square by 2a square, and that mu is your variance. So I think option B should be the right one again, but some others have taught it to be a square also. So I have seen a postulate, like I can attach the link where I have seen the postulate to be the B. Okay, so maybe B is the right one, or maybe that particular link has shown the wrong option. So we do not know even about this particular question. This year the question paper is like, you cannot tell that this is the answer or that is the particular answer, because I found that the many answers are so confusing. In the part C especially, you feel that option A is right, B is right, C is also right, and then you'll be given with options A and B and C and D, where you'll be asked to write which among the following are the right ones. Like, it is so confusing. Maybe we should try to increase our standards of learning for CSIR, we should begin with BSc chemistry and then we have to study the master's chemistry, because this time the inorganic was totally from the BSc chemistry, the graduation. Okay, so we'll try to change our the mode of studying for entrance. Maybe the upcoming videos I'll try to make it more basic other than studying the master's topics, because that anyways you will read from your side. Okay, anyways, and then the change in the entropy for a reversible adiabatic process is zero, a simpler one. Standard cell potential, the delta G minus NFE cell, if you calculate, this value will get in coulombs, but 1 coulomb is 1 joule volts. So if you convert that, you will get this particular as joule mole inverse. Okay, but you have, like, you do not have this particular answer, so you have to convert it in kilojoules. So minus 212.300 kilojoules. 3 is the right choice. Okay, and then if the units of the rate constant for a reaction, like I did not write the complete thing, I know here some liters should also be present, but roughly concentration per 1 minus n is most common, the general formula. So in that, if I write 1 minus 4, I will get mole minus 3, right? So the order is fourth, like fourth one is the right option, that is the order is 4. The lowest energy state of 1s1 2s1 electronic configuration according to Hund's rules. So 1s1 2s1, this is the configuration, right? So as it is a 1s orbital, L value will be 0. As the L value is 0, the term will be singlet, capital S, right? And then 2s plus 1 is 2 into 1 plus 1. 2 into 1 plus 1 is 3. So triplet. And then J value will be L minus S. Okay, yeah, J value will be L minus S. So 0 minus will not be there, it will be modulus half plus half 1. So triplet S1 is the right choice. Okay, the same which we have solved there previously, the ground state, the same fashion we have to do here. Okay, this is accordance to the Hund's rule. Like I have told there, that Hund's rule is the major thing which plays an important role over there, right? And then if all the lattice points of an FCC structure are occupied by uniform hard spheres, the volume, the fraction of volume he asked. Okay, so this was the way you had to do the total volume to the actual volume of that, I mean the FCC one to the total volume. So 4 by 3 pi r cube, and for FCC the radius is something around root 2 a by 4 whole cube by a cube. So in this fashion, if you do, the right option will come out to be pi by root 2 6. Okay, and then this one, I think the origin of colligative property has to be the volatility of solute molecules, if I'm not wrong. Okay, not sure, not pretty sure, but yeah, it has to be volatility of the solute molecules. And then the graph that represents the Langmuir adsorption isotherm is this particular graph, the fourth one. Okay, the fourth one. I do not want to discuss the questions which I am doubtful. Okay, so I'll not teach the other things. And then, yeah, this particular question, identify the pair of molecules which are isoelectronic as well as isostructural. Okay, if you look at this particular question, the palladium ppс3 taken 4 is 18 electron, the vanadium is 17, the chromium CO6 is 18, this is 18, this is 18, and this is also 18. All are 18 except B. Okay, so B is not B is 17 electrons. So any option in the B combination will not be the right one. So first one cannot be the right choice. And then among these three, if you observe carefully, A and F, A is palladium and F is nickel tetracarbonyl. Okay, this is the right one. We'll discuss this later. Look at A and D. A and D. A is a tetrahedral molecule, right? Palladium, zero oxidation state. I mean D10, sp3 tetrahedral. But this is like nickel, neta 5, C5, H5, NO. NO is of course a 3 electron donor here. As I've told, you have to balance in such a way that 18 electron comes. The geometry will not come out to be tetrahedral for this, but we have to see that it is isostructural and isoelectronic. So this cannot be the right choice. And if you look at C and E, C is rhodium pps3 taken twice chlorine, and E is here nickel tetracarbonyl. Okay, rhodium pps3 taken twice Cl, and this are not again tetrahedral. This is not tetrahedral, the rhodium complex. Isoelectronic but not isostructural. So the right option is this A and F, because palladium PPH3 taken 4 and nickel tetracarbonyl both are tetrahedral geometry and both are isoelectronic. Okay, so 2 is the right one. And then here this particular question, match the fluorescence colors given in the column. For this, if anyone has marked the option 3, I think that is the right one, because the red is for terbium and europium 3 exhibits the green color, the green fluorescent color. Okay, so 3 is the right one. And then this I wrote wrong. See, I have written here guanine, and then like I know that the platinum binds to the guanine but not cytosine, but still I marked wrongly. So it's my problem that, you know, I think something and I mark something. Please, you people, don't do that mistake. Okay. And yeah, this question, in the morning video I made a mistake. I said both are eclipsed, both are staggered. No, rhenium is eclipsed and this is staggered. Okay, one of them was correcting it, but then I told no, it is eclipsed. I'm sorry for that. I mean, this is eclipsed and this is staggered. I said both are staggered. No, that is the wrong one. And this question I have explained in the morning, like I am unable to find the right choice among all the four. Like I feel that all the four, I mean, these options cannot be the right one, because these three, there is metal bond in all, but in beryllium there is no metal bond. So A is not the right option. So 1 and 2 cannot be the right one. Among 3 and D, I have told that the geometry around the central atom is planar for all. The geometry around the central atom is planar in 1 and 2 only. Once it is planar for all, you cannot tell that it is planar for 1 and 2 only. That is, the C and D cannot be together. This cannot be together, so even this cannot be the option. So answer should be D only, right? But D only also cannot be the option, because the oxidation state is +2 in all of them. You can observe that. So this is like a controversial question. I cannot tell if this question is correct or not. If there is something wrong, if you have attempted, you are going to get 4 marks for sure. Not a problem with that. But if I am going wrong somewhere, then there will be a problem. Anyways. And then even this, I mean, I don't know how can I do this kind of mistakes. I thought this is also iron. Okay, without looking at the metal present, I just told that this is outer sphere. No, this is inner sphere. The cyanide is a bridging here, a bridging ligand. Okay, so this is inner sphere, this is also inner sphere. So the correct option is 3. It's not 1 as I have told in the morning. Okay, it's the third option. And this is ABC. Like I think you knew it. Okay, these are easy. And the water exchange, it has a particular order in which we'll see that the chromium is the exchange for the chromium is greater than vanadium, right? Anything else over here? This is alene molecule. I am still in doubt. I'm not sure. Like I'll try to check out from Banwell the correct one and then let you know. And yeah, this question, yeah, this is the right choice. As I've told, sigma to pi, the delta lambda difference should be either 0 or plus or minus 1, the capital lambda. Okay, here it is sigma to sigma, G rate to G rate. G rate to G rate is not an allowed transition. So 1 and 2 cannot be the answer. It has to be either 3 or 4. So G rate to un-G rate is allowed, and this should be 0 or plus or minus 1. So sigma to pi is difference is 1, but here it is 2. So third one is the right option. Okay, number of EPR lines is 7. Fine, that is not a problem. And this question, in the phase diagram of water, the solid liquid boundary has a negative slope. The reason for this unusual behavior is due to density. Like you might have learned in your basics that some at 4 degrees Celsius, when the water converts into ice, there's the density change which occurs. Okay, like volume, entropy and enthalpy do not have any effect on the melting, but density do affects on the melting. So this is the correct option. Okay, and what else, did I leave anything? So if I find anything else than this, like I think I have to read few books to even get other answers. Just by our own understanding, it's very difficult to tell the answers. Even this one, like I feel second one is the right one, because size of arsenic is more than that of phosphorus. That's true, right? Nitrogen, phosphorus, arsenic. So definitely B is the right choice. So 3 and 4 cannot be the answer, which says 2 is false. It should be 1 and 2. So among 1 and 2, One says that this is thermally less stable than PCl5. Okay, so thermal stability depends upon the covalent character according to me. Like thermal stability is directly proportional to covalent character. But here he has given the size in the B option, and first one nowhere it is size related. So I feel that statement 1 and 2 are true, but 2 is not the correct explanation for A. Okay, so this is the right answer. So that's all for now. Maybe if I find anything interesting, then I'll let you know, right? Thank you.